My friend mentioned to me that he would like to see me do something more with discussing the coding that I do. I recently had shown some of my LaTeX on screen as I built a diagram, and I have been spending a lot of time this summer working with Python. LaTeX, the language that I'm better at than Python, and I'm still learning a lot about Python. Looking at the t-shirt problem that I did, I had set this up and done it on the chalkboard and done the calculations on my Casio graphing calculator. But then I thought I could go back and see if I could code that with Python. Don't know that I've used SymPy before, but it looks like that is the library to use for matrices. I looked into it and I put together some code, and I'm going to run through some code here. And one of the interesting features I found about SymPy is that it can do LaTeX output. We're going to see that in the end and then see how that compiles. I'm on a Linux system, so I have to have a shebang in here at the beginning, and then I call in my library, and then I build a matrix. I'm calling this matrix T because this is the solution for the t-shirt. You can call the matrix anything that you want, and you don't have to build it vertically like this, but if you're more of a visual person, this is one of the places where Python will allow you to have this spacing in here like this. Python is usually sensitive to spacing. This seems to be kind of an exception where we can stack the matrix if we choose to, so that it looks like a matrix, but it doesn't have to. It can be listed out and it will work. Once we build our matrix, then I built a variable matrix because I want to be able to display it the way that I had drawn it on the board, where I have just the solution as like a vector. So I built that variable matrix in here, which this doesn't show the vertical spacing, but it is a vertical matrix. On screen here, I have demonstrations of both building it so that it looks like the vertical matrix in the 2 dimensions, and then I have this example with the variable matrix where it's just all linear. This is really a 4x1 matrix. It will look like a vertical vector. I ended up having some problems with screen recording here, so we're going to see some jumps. I build a variable called solution, and then I take my matrix and I do the RREF. That function outputs what they call pivot points, which are specific places in the matrix where you see certain things occur. That's not really important to what I'm doing, so I put in there pivots false so that I don't see that output either on my screen or in what's saved to file. It's meaningless to me and I don't want it, so that's why pivots are false. And then I have another one where I created the variable called answer. I just call out that last column of the matrix. You see I put in a 4 there because SymPy seems to be like the pandas library, which I've spent a lot of time using. It starts indexing at 0. So if you have 5 columns, your 4th column is really your 5th column because you count from 0 instead of from 1. So that's why it's like that. Another feature that you can do with this, if you know it's absolutely the last column that you want, weirdly, if you put in -1 for that, it knows that's the last column. So I could have had a 4 in there or a -1, and that would have been my 5th column. And then I start putting print commands in here, which displays this to my terminal as visual output. I don't run this inside of an IDE. I run this straight in my Linux terminal. That just prints to terminal, and it doesn't render the matrices nice and pretty. But the next thing that I'm going to do after I print to the screen is I build this variable called output, and I declare a file name. And I don't know that this was originally meant to go directly to tech, but it works. And tech is essentially a text file. It's just plain text, and the system seems to like it. It's working on a Linux system. I don't know how this will work on other systems. I imagine it should be all right. And then I build the preamble just like I would if I was working on a LaTeX document. I had to have some slight variance in here from what I would do on a normal LaTeX document, because I'm going to package all this and put it into a file, and then we're going to be able to pull that up in a LaTeX editor. So I build my preamble here. I have to tell what document class that I want, what packages that I want to use, and I have to begin my document. Then I built a space variable, which is just going to put some separation between the two outputs that I have, because I have the first output, which is the solution matrix that has all the columns, and then I have the next output, which is the vectors, which just shows the variables and the solutions. So those are my two outputs. So I put a space variable in here that's going to separate those two in the LaTeX document. And then I have to end the document in LaTeX. The next thing that I do is I have to fill in the tech document that I've declared as output. I'm opening that file and I'm writing to it. The W is basically writing, I believe. So we say file.write, and then the thing that we want to put into the file goes in the parentheses. So I'm going to pull in the preamble, and then the /n adds a new line. So it's a line break. And then I'm going to pull in the solution, but I have the LaTeX function here, which is going to take the solution that is being produced by Python and converting it to the LaTeX language. I'm adding the space variable that I had declared earlier to that. Then I'm going to do a new line, and I'm going to write the variable matrix that I created earlier, and I'm going to set that equal to the answer matrix that I created earlier, and then add a new line in there. Earlier, when I printed to the screen, I used an F string, which pulls that information in and then prints it to screen, but I have to rewrite this a little bit so that it converts it to LaTeX code and puts it in the file. And then lastly, I'm going to write the end document into that. And then also I have another print line here, and this just gives me feedback to my terminal to let me know that it's done processing. It's written all this to a document and saving it onto my computer. And then once we do that, we can open that document in my tech editor, which I use TexMaker. I really like that one. And you can see a preview show up on the screen when you edit, because it's not what you see is what you get. So it's very handy to have that preview screen. And then you can open up after you've processed that and see the PDF output. The only thing that I really had to edit is I put some returns, and I had to add the $signs so that will render the mathematics text. But other than that, everything had been built directly from the Python. So this gives a demonstration of a little bit of Python and a little bit of LaTeX. Hopefully this was interesting to somebody. It ties in with the problem that I did the other day in solving the t-shirt problem. It allows another avenue for how we might solve that. So we're using some of the Python code, and then we can output that in a very nice way with the LaTeX. I tried to find this t-shirt for sale using a Google image search and I couldn't find it. So I don't know if this was just like something specific made by a small group of people or what. It looks like it was posted on Pinterest. I just did a search through DuckDuckGo for math t-shirts. That's how I came across it. Cheerful Calculations.